Welcome to This Explainer. Today, we are diving into the ultimate mystery of something you literally experience every single second of your existence. We're talking about the one-way direction of time. You know, it's this relentless force we all feel. Yet, when you pull back the curtain on how the universe actually works, things get weird. Seriously weird. In fact, time is actually one of the most hotly debated subjects in modern physics right now.
Consider this poetic idea from the Roman poet Ovid. It perfectly captures our everyday, deeply visceral experience of time. We all feel it passing relentlessly forward, right? You age, you never get younger. You remember yesterday, but you absolutely can't remember tomorrow. It just feels incredibly obvious to us that time flows like a river in exactly one direction.
But what if I told you that the fundamental laws of physics actually allow a shattered egg to spontaneously unbreak, rise up from the floor, and reassemble perfectly right in your hand? No way, right? You'd think it was a magic trick. But surprisingly, this bizarre allowance in the math reveals a massive paradox in how we understand the very fabric of our universe.
So let's get into Section 1, the paradox of time and shattering the illusion. We really need to dive into this paradox, where our everyday, cozy feeling of time crashes headfirst into the cold, hard equations of physics. This is where things start to get wonderfully weird. Here is the absolute crux of the problem. At the microscopic level, all of our significant fundamental physical laws are time reversal symmetric. What does that mean? It means they work equally well whether time is running forwards or backwards. Imagine watching a video of atoms colliding. You literally wouldn't be able to tell if it was playing normally or in reverse. The fundamental laws give us absolutely no explanation for the one-way macroscopic processes we see every single day, like that breaking egg.
Moving on to Section 2, the intrinsic time camp, or time's inherent flow. To solve this paradox, scientists and philosophers basically divide themselves into two broad camps. We're going to start with the intrinsic camp. Now, these folks argue that time has its own independent, built-in arrow, completely regardless of what's happening to the matter inside the universe.
Defenders of this dynamic theory argue that our everyday intuitions shouldn't just be tossed out the window. They point to the philosopher Janan Ismail's concept of the felt whoosh of experience. I love that phrasing. For them, the visceral, everyday flux of temporal experience proves that time is active, that the present physically and objectively produces the past. Time itself, they argue, is actively passing.
There is a stark contrast here between two completely different views of reality. On one side, we have our human-centric, manifest image of flowing time, the river we all feel we're swimming in. But on the other side, we have the totally counterintuitive, strictly physical, scientific image favored by Einstein and modern physics. And that image treats time as a static block of space-time, where the past, present, and future literally all equally exist.
Okay, Section 3, the extrinsic time camp, looking at the arrow as a pattern. This brings us to the opposing side, which pivots entirely away from human intuition. They claim that time itself has absolutely no inherent direction at all, and that the so-called arrow of time is simply a pattern that just emerges from the stuff happening inside of time. They argue that time having an arrow is really just an illusion created by physical processes. Think about it kind of like space. When you stand on Earth, space definitely feels like it has a down direction, right? But that's just because we happen to live on a giant planet with gravity. If you were floating out in the vacuum of deep space, down simply wouldn't exist. The extrinsic camp argues that the one-way arrow of time is similarly just a circumstantial illusion. This leads right into Section 4, the entropy explanation, from order to disorder. So if time doesn't inherently flow, why can't we unbreak that egg? Well, the most popular explanation relies on a thermodynamic concept championed by the brilliant physicist Ludwig Boltzmann way back in the late 1800s. That concept is entropy. Now, entropy is effectively a measure of wasted energy and disorder within a closed system. When a glass shatters on the floor, or when a piping hot cup of coffee cools down to room temperature, or, when your phone battery dies, these are all examples of physical systems naturally moving from low entropy to higher entropy.
A simple box of sand perfectly illustrates Boltzmann's statistical insight. Just imagine, step 1, if you have black sand neatly layered on the bottom and white sand on top, that is a highly ordered, low-entropy state. But once you start shaking the box in step 2, the sand reliably turns gray. Why? Well, because there are just a handful of ways for the particles to be neatly separated, but there are vastly, completely, unfathomably more ways for them to be mixed up. It's not some magic force driving time forward, it's honestly just raw probability. To really grasp the sheer scale of this probability, just consider this massive number. When you realize that a mere few teaspoons of water contain 10 to the 24th power molecules, and they're colliding with each other trillions of times a second, you see that entropy is basically an unstoppable statistical avalanche. The egg doesn't unbreak because the statistical odds of all those molecules perfectly aligning to jump back into an unbroken shell are so infinitesimally small, it would take far longer than the entire age of the universe to happen even once.
Which brings us to Section 5, the past hypothesis, the big loophole. Okay, so it turns out there is a massive loophole in Boltzmann's math. If entropy is just based on the statistical probabilities of particles moving around, the math dictates that entropy should actually be increasing in both directions of time. It should be increasing when we look into the future, sure, but it should also be increasing when we look into the past. Yet, obviously, when looking into the past, we clearly see order, not disorder.
So the crucial takeaway here is that to make this whole entropy explanation work, physicists must rely on something called the past hypothesis. This essentially means we just have to blindly accept that the universe somehow began in a highly ordered, incredibly low entropy state at the Big Bang. It's basically an unexplained boundary condition of reality.
As Nobel laureate Roger Penrose points out, it is an incredible puzzle. I mean, cosmologists desperately want a theoretical mechanism, something like the theory of cosmic inflation, to actually explain why the universe started in this ridiculously special low entropy state. They don't want to just blindly assume it to make their math work out. It honestly remains one of the absolute greatest mysteries in modern science today.
Moving on to Section 6, Other Arrows of Time, and the taxonomy problem. Let's see how all this builds into what philosophers call the taxonomy problem. If entropy is the ultimate master arrow of time, we have to figure out if it successfully drives all the other distinct ways that we humans experience the flow of time.
Because, we observe several of these mini arrows in nature. Think about it. We effortlessly remember the past, but literally never the future, which is the memory arrow. We see the universe expanding but never contracting. That's the cosmological arrow. And we know for a fact that causes always precede their effects, which is the causal arrow. So the big question is, do all of these stem from entropy?
Take the memory arrow, for example. Physicists argue that while storing a memory creates a highly ordered, low-entropy trace physically recorded right there in your neurons, the biological process of doing that actually burns energy and generates bodily heat. So while your brain gets a tiny bit more organized locally, that heat goes out and increases the overall entropy of the universe. In this way, your very psychological experience of time is directly tied to the universe slowly winding down. Kinda wild, right?
Then there is the cosmological arrow. Some scientists, like physicist Richard Muller, completely flip the script here. They argue that the ongoing physical expansion of the universe isn't just stuff moving apart. They claim it is actually the active creation of 4D space-time. Under this theory, the expansion of the cosmos is constantly generating new nows, and that is what physically creates the flow of time itself.
As for the causal arrow, why do causes happen before effects? Well, physicist Sean Carroll argues that cause and effect isn't even a real thing at the fundamental microscopic level. Those particles just bounce around completely symmetrically. Causality only emerges at our large human scale because the low entropy past gives us causal leverage over the high entropy future. We can drop an egg and break it for sure, but we have absolutely no leverage to reverse the process. Finally, Section 7, the great unknown, reversing the arrow. We've covered a ton of ground in this explainer today. We've shattered the illusion of a flowing river, we've uncovered the cold statistical reality of entropy dictating our lives, and we've hit the massive roadblock of the Big Bang's mysterious, unexplained initial conditions. Which leads us to a final, truly mind-bending scenario. If time's arrow isn't built into the fabric of the universe, and is truly just a statistical pattern based on entropy, what realities might exist where the pattern runs the other way? Think about it. If a distant region of the cosmos had a reversed arrow of time, would conscious beings there walk backwards into infancy, while perfectly remembering the future? I am going to leave you to ponder that one. Thanks for joining me on this explainer, and keep questioning the reality around you.